Alright, let's talk about even and odd functions. Before we do this though, let's just talk about how to transform functions. If you have something like f of x is equal to x squared, this is our function. And let's say if we wanted to move this function up by 1 unit. Well, how would we do this? Well, let's say if the new function is g of x, what we do is we take whatever y value that it outputs and we add how many we want to move it up by. So for example, if we wanted to move f of x is equal to x squared up by 2 units, well, it would just, the resulting function, the transformation, would be x squared plus 2. And you'll notice this is the same function, it's just moved up by 2. Every y value you have in the original function, well, now it's increased by 2 units. For example, when x is equal to 0, you'll notice that the y value is also equal to 0. However, in our new function now, when x is equal to 0, now our y value is equal to 2. So everything moved up by 2 units. Adding moves it up. Likewise, subtracting moves the function down. So if you want to move your function down by 2 units, well, you would just subtract 2 from the function. If you want to move it down by 3, 4, 5 units, same thing. So if you want your function to move to the left, well, all you have to do is, instead of an x squared, you would have let's say if you want to move 2 units to the left. Well, instead of x squared, you would have an x plus 2 squared. So adding on the inside of the function moves it to the left. And likewise, subtracting on the inside of the function moves it to the right. So it's always the opposite of what you expect. Adding on the inside moves it to the negative side. Subtracting on the inside moves it to the positive. So you can move, let's say, f of x equals x squared. You can move it up, down, left, and right in any sort of combination. So if I wanted to move my function, let's say, 6 units to the right and 2 units up, well, we know that adding 2 to the end of the function moves it up by 2. And we know that on the inside of our function, well, if I wanted to move it 6 units to the right, I would just subtract 6. And boom, that's our resulted transform function. If I wanted to make this function move 5 units to the left and 5 units down, how do I do this? Well, we know that subtracting on the outside of the function moves it down. In this case, I wanted to move it down by 5 units. So this would just be x squared minus 5. And now I would add to the inside. I will just add to the inside of the function to move it to the left. Let's talk about even and odd functions. Even functions map onto itself when reflected across the y-axis, while odd functions map onto itself when reflected across the origin. Basically, when a function is reflected across the x and y-axis, it maps onto itself. Let's take a look at some examples. Let's say if we have the function f of x is equal to x squared. What do you notice about this graph? Well, right over here, I've drawn this y-axis, right? I highlighted it in black. And what you notice is that if I draw this line in the middle, this function is perfectly symmetrical about this line. So that's what an even function is. It's symmetrical about the y-axis. If we were to take a look at an odd function, which is f of x equals to x to the third power, well, what do you notice about this graph? This might be a little more complicated. Let's start off by taking our original function, and let's reflect it over the x-axis. So let's say if I were to take this function, and I were to reflect it over the x-axis, it would look something like this. Right, and now what I do is I take this new function, and I reflect it across the y-axis. And now I end up getting my original function. If you reflect this over the x-axis and then the y-axis, and then you end up with the same graph while it's odd function. So let me just replay that again, just so you can see visually. I reflect this over the x-axis first, and I get this. Then I reflected this over the y-axis, and then I end up with the same function as my original function. Here's just some even functions. So you have f of x is equal to absolute value of x. You have cosine of x. You have x to the fourth power. And all of these are even. You notice how they're symmetrical about the y-axis. And here are some examples of odd functions. F of x is equal to sine of x. G of x is equal to x. And then x to the fifth power. And you'll notice how if I reflected all of these, actually, let's talk about, let's say, g of x, for example. If I were to take this function and I were to reflect it across the x-axis, well, I would get this resulting graph, right? And then if I were to take this resulting graph and I were to reflect it across the y-axis, well, I would get back to my original function. So these are just some examples of odd functions, and these are even functions. So we have these three examples, and we want to find out if the function is even, odd, or neither. So this is another thing about these even odd functions. Functions don't have to be even or odd. Let's start off the first problem. So is this function even, odd, or neither? Well, if this function is even, we know that it would be symmetrical about the y-axis. But in this case, it's clearly not symmetrical about the y-axis. So we know that it can't be even, right? So it's either odd or neither. Now, let's see if this function is odd. So first, let's start off by reflecting this function about the y-axis. So if we reflect it about the y-axis, we would get something that looks like this. So it would be like this, and all the way up here, all the way down here, and all the way up here. This side of the function would look something like this. So this, go down, up. Okay. And if I were to reflect this across the x-axis, well, then the function would look like this. And you'll notice how it matches our original function. Therefore, this is an odd function. This is an odd function. Because if we reflected it across the x-axis and then the y-axis, well, it would map back onto itself. And a quick way to tell something if it's an odd function, well, you'll notice how when x is equal to -3, our y value is equal to 1. And when x is equal to +3, our y value is equal to -1. When our x value is equal to -5, our y value is equal to -1. And when our x value is +5, our y value is equal to +1. So for odd functions, if you were to take the coordinates of any odd function, you'll notice a pattern. When you plug in, let's say, an x value, you're going to get out a y value, right? However, if you plug in the negative of that x value, you're going to get the negative of the y value, right? For example, plug in x value, you get a y value. If you plug in the negative of the x value, so in this case, negative of -3 is just +3, where you get the negative of the y value. So it's like the x and y values both get negated at the same time. Right? You take the negative of this, you take the negative of this, well, there's a coordinate that matches up with that. So that's the quick way to identify if a function is odd or even based on the coordinates. So let's say if I take this point, 4, 0. If this function is, let's say, odd, well, there's a point that's -4, negative 0 or just 0. And in this case, that's true. All right, now number 2. Is this function odd or even? Well, it's definitely not even, and there's no way this function is odd. Just from the logic that we did from this problem. If you take a look at it, when x is equal to 1, the y value is equal to 1. So if this function was really odd, then if the x value is negative 1, then y value is negative 1 as well. There should be a point that's like this. And in this case, there's no point that's like this. So this function is neither. And then the last function, symmetrical about the y-axis, has to be even. Now here's something interesting about odd functions. I want you to take a look at this. So let's say we start off with the same odd function f of x is equal to x to the third power, and we reflected it across the x-axis. Here's what it would look like. It would look something like this. This is across the x-axis. Now let's see what happens if we take the same function and we reflected it across the y-axis. What would it look like? So we reflected it across the y-axis. Well, this part of the function would map onto this part. So this part would map onto this part, and then this part of a function would map onto the other side. And notice, so this is across the x-axis, and then this one's across the y-axis. And what you notice is that, whoa, these two functions, they're the same thing. So that's something really cool. And this means that if you were to take, let's say, f of x, let's say this is an odd function, and you were to reflect it across the x-axis. So if you were to take f of x and reflect it across the x-axis, it's going to be the same function as if you took f of x and you reflected it across the y-axis. Reflected it across the y-axis. So that's the main point I want to get across. F of x reflected about the x-axis is the same function as f of x reflected across the y-axis if the function is odd. Now let's come up with some formulas to find out if functions even or odd. What you notice is that for even functions, let's say if I pick this value. This value is negative 2, 4. And I pick this value. This point is 2, 4. Let's select more points. Let's say this value right over here. This is negative 4, 16. And then this value right over here is 4, 16. So what you notice is that if I have a function that's supposed to be even, I have f of x, well, if I plug in the negative of this x value, I get the same y value. In other words, f of x, in order to tell if a function is even or not, f of x has to be equal to f of negative x. So if you were to plug in an x value for an even function, it should be the same. It should output the same y value, notice it has the same y value as if I plugged in the negative of that x value, right? If I plug in positive 4, I get out 16. If I plug in the negative of that x value, which is negative 4, I still get 16. So that's what this part basically means. F of x is equal to f of negative x. And for odd functions, it's a little bit more complicated, but the formula for odd functions to find out if something is odd is f of negative x is equal to f of negative x is equal to negative f of x. So if we have f of x equals x to the third power plus x to the second power, f of negative x would represent the same function except it's reflected about the y-axis. and negative f of x would represent the same function, except this time it's reflected about the x-axis. Let's say if I have the function f of x is equal to x to the fourth plus 1. Is this odd? Is this function odd, even, or neither? The first step is always to plug in f of negative x. So this is always going to be the first step. If you want to find out if a function's odd, even, or neither, you want to find out what f of negative x is equal to. Now we know that f of 1, okay. F of 1, what is f of 1? Well, everywhere we see x, we replace it with 1. F of 2, right? Everywhere we see x, we replace it with a 2. So f of negative x, well, everywhere we see x, replace it with a negative x. So we have negative x to the fourth power plus 1. And we know that negative x to the fourth power is just equal to x to the fourth power. Right, if you have 1, 2, 3, 4 x's multiplied together, all of these negatives cancel out to make a positive. These x's cancel out to make a positive. Positive times positive is positive. If your exponent is even, the result is always going to be positive. If your exponent is odd and you're raising a negative power to an odd exponent, it's always going to be odd as a result. For example, negative x to the third power is always going to be negative. If it's an odd power, let's say negative x to the seventh power, negative x to the ninth power, if the exponent is odd, it's going to be negative. So we just conclude that negative x to the fourth power is x to the fourth power, and then we still have this plus 1 at the end. And what you notice is that f of negative x, when we substituted negative in for x, well, we have the same result as f of x. Right? X to the fourth power plus 1 is f of x. So all I did was substitute this right over here, and we just found out that f of negative x is equal to f of x. Therefore, our function is even. Right? The even formula for functions is f of x is equal to f of negative x. And in this case, well, that's true. Alright, I got a couple of practice problems. Probably going to do like 5 because I'm lazy. So, feel free to give it a go. Start with number 1. I have the even and odd formulas, by the way, up top. So, we want to find out if this is an even, odd, or neither. How do we do this? We'll first start off by plugging f of negative x into our first function. So if we plug in negative x, everywhere we see x, we replace it with a negative x. So everywhere we see x, instead of x to the third power, we have negative x to the third power. Instead of minus x to the second power, we have negative x to the second power, plus 4 times negative x plus 2. Negative x to the third power is just negative x to the third power, minus x, negative x to the second power is just x to the second power, just x to the second power. 4 times negative x is negative 4x, and you still have this plus 2. So obviously, this result that I have is not the same as our original function. Our original function is x to the third power, all of this business. However, this right over here is nothing like what we have originally. Therefore, this function can't be even. This function can't be even. because when we plug in negative x for f of x, well, our result is not the same as what we had originally. But is this an odd function or not? Well, in order for a function to be odd, we need to have f of negative x. We've already found what that is. It has to be equal to negative of f of x. Now, what's negative f of x in this case? We know f of x is equal to x to the third power minus x to the second power plus 4x plus 2. So negative f of x, well, this would just be the negative of all of this. Negative of x to the third power minus x to the second power plus 4x plus 2. This is negative f of x. Just take the negative of whatever you had originally. So this would be negative x to the third power plus x squared minus 4x minus 2. And you notice how f of negative x is not equal to f of negative x, meaning that this function right over here is not either. It's not odd or even. It's neither. All right, because it does not follow any of this formula. It does not follow these two formulas. On to the next question. F of x is equal to negative x squared plus 10. Is this even or odd? Let's find out. So we have f of x. It's important to write out everything, so let's just write out everything. F of x is equal to negative x squared plus 10. First thing we want to do, everywhere we see x, replace it. Everywhere we see x, replace it with a negative x. So f of negative x is equal to negative of negative x to the second power. Right, we just replace this x with a negative x plus 10. Negative x squared is just x. And don't forget the negative sign out front. Plus 10. Right, negative x to the second power is just positive x to the second power. And this is just going to be negative x to the second power plus 10. And what you notice is that, well, we end back up with our original function. In this case, when we plug in negative x for our function, we get back our original function, right? When you plug in negative x squared, negative of negative x squared plus 10, well, after some simplifying, we get back to our original function. Very same thing. Therefore, this is an even function. F of negative x is equal to f of x. Let's do number 3. X to the third power plus 4x. Is this odd, even, neither? Well, first step, once again, what we do is everywhere we see x, replace it with a negative x. So everywhere we see an x, we replace it with a negative x. So you get negative x to the third power plus 4 times negative x. Simplifying this, we get negative x to the third power minus 4x. Right, 4 times negative x is negative 4x. Negative x to the third power is negative x to the third power. Now, this function for question number 3, we know that this function can't be even because the result of simplifying g of negative x is not equal to what it originally was. Right, g of negative x is not equal to g of x, which is what we had originally, right? X to the third power plus 4x is not equal to negative x to the third power minus 4x. So this function is not even. Is this function odd though? Well, what's negative of g of x? Well, we know g of x is equal to x to the third power plus 4x. So let's substitute that in here. So we have negative of x to the third power plus 4x. And now we can distribute the negative sign so that we get negative g of x is equal to negative x to the third power minus 4x. And what you notice is that these two things match up. So g of negative x is equal to negative of g of x. Therefore, this function is actually odd. This function is odd. And you notice something cool about this. Odd functions, what you'll notice is that the exponents of odd functions are odd, and the exponents of even functions are even. So if there's no horizontal shift in the graph, if there's only even exponents, it's going to be even. If there's only odd exponents, it's going to be odd. It's not always the case if there is vertical shift, but in a lot of the cases, especially if polynomials, that's the case. All right, let's do number 4. F of x is equal to negative x to the third power plus 5x minus 2. First step, everywhere we see x, plug in negative x. So everywhere we see x, in this case, this x turns into a negative x. This x turns into a negative x, right? And then minus 2. Now, simplify. Negative x to the third power is going to be negative x to the third power. And we still have this negative sign in front. Negative, negative makes a positive, right? This cancels out. So we get x to the third power, and then 5 times negative x is negative 5x minus 2. And what you notice is that, well, f of negative x is not equal to f of x. Therefore, this function is not even. So that's the first thing we can conclude. Now let's see if this thing is equal to negative of f of x. Let's see if this is odd. So we know f of x is equal to all of this business. So let's substitute that in. We get negative x to the third power plus 5x minus 2. So negative, let's distribute all of this. This makes positive. Negative 5x plus 2. And what you'll notice is that negative f of x is not equal to f of negative x. Right? These two things are not equal to each other. This one's minus 2, this one is plus 2. Therefore, this function is neither even nor odd. Final one, question number 5. F of x is equal to square root of x to the 4th power minus x squared plus 4. Once again, let's just do the same process. Everywhere we see an x, replace it with a negative x. So this is going to be the square root of negative x to the 4th power minus negative x to the 2nd power plus 4. Negative x to the 4th power is just x to the 4th power minus negative x to the 2nd power is just x to the 2nd power, and then plus 4. And what you'll notice is that this is actually the same thing as what we had originally. In other words, f of x, which is our original function, is equal to f of negative x, when we plug in negative x into the function. Therefore, this function is even. Hope y'all enjoyed this video.